So how are we going to graph inequalities on the coordinate plane? So this is going to work very similarly to how we graphed equations of lines, y equals mx plus b. All right, but there's some added things because I'm not dealing with an equation, I'm dealing with an inequality. Okay, so A is saying y is bigger than or equal to negative 2x plus 3. So I could plot points just like I would if I was in slope-intercept form. All right, I start at my y-intercept of 3. I go down 2 to the right one, down 2 to the right one, down 2 to the right one, down 2 to the right one. Or I could go up 2 to the left one, up 2 to the left one, up 2 to the left one. All right, now this is saying, the symbol is saying y is bigger than or equal to negative 2x plus 3. So since I have equality, then I'm going to have a solid line. Okay, a solid line connecting these points. Okay, so this is called my boundary line. This is called my boundary line. Okay, because it's going to set the boundary for which way I shade. Because remember, I'm dealing with an inequality. So this is saying anything bigger than or equal to negative 2x plus 3 is a solution. All right, so since it's bigger than, what I'm going to do is I can shade above this line. Because it's saying anything on this line and anything bigger than this line satisfies this inequality. So I'm going to shade everything above this line. Okay, because it's saying anything bigger than that line, I'm going to shade. Okay, that is the graph of this inequality. It has my boundary line, and then it has what is called a solution region. Any point that I find in that solution region or on this solid line will satisfy this inequality. Okay? Another way we can figure out where to shade is to test some points. So like if I tested 0, 0, plug in 0 for x, plug in 0 for y, I would be left with 0 is bigger than or equal to 3. That's not true. That's not true. So I do not want the region where 0, 0 is located. So I got to shade away from 0, 0. Okay? Let's test some other points. Negative 1, 5. So if I plug in 5 for y and negative 1 for x, I would get 5 is bigger than or equal to negative 2 times negative 1, which is 2. 2 plus 3, which is 5. So 5 is bigger than or equal to 5, which is true. 5 equals 5, and I have equality here. So I want that one. What about 6, 3? I plug in 3 for 6, I plug in 3 for y is bigger than or equal to negative 2 times 6, which is negative 12. Negative 12 plus 3, which is negative 9. 6, 3 satisfies this inequality because I get 3 is bigger than or equal to negative 9. All right, notice 6, 3 is right here. That is in my solution region. What about 0, negative 2? 0, negative 2 is right there, which we can see from our graph that it's not a solution. But what if we didn't have our graph? Well, we would need to plug in. Negative 2 bigger than or equal to, negative 2 times 0 is 0. 0 plus 3 is 3. Is negative 2 bigger than or equal to 3? No, it's not. So that's not a solution to my inequality. All right, let's do another one. Y is less than 1/2 x minus 1. So again, let's plot points like we were graphing in y equals mx plus b, like we were graphing this line. So I start at negative 1, and I go up 1 to the right 2, up 1 to the right 2, so on and so forth. Or I could go down 1 to the left 2. Down 1 to the left 2. Down 1 to the left 2. All right, now, I don't want to make a solid line here because I do not have equality. All I have is y is less than 1/2 x minus 1. So since I don't have equality, I'm going to do a dashed line. Because remember, this is just my boundary line. Okay, so I'm not actually including this line. I'm just saying that this line sets the boundary for where I'm going to start to shade. So I'm going to do a dashed line connecting these dots. Don't forget my arrows, because this boundary is going on forever and ever. All right, and it's saying y is less than 1/2 x minus 1. So less than, I'm going to shade below this line. Because if I tested 0, 0, if I tested my origin, I would get 0 is less than -1. That's not true. So I don't want to shade the region that has 0, 0, my origin. I want to shade away from that. Okay? So I'm shading below. So I'm just going to shade there. And this represents my solution region. Anything in that region is going to work. All right, so let's test these points. -2, -2. All right, if I plugged in -2 for y and -2 for x, I would get -2 is less than, half of -2 is -1, -1 minus 1 is -2. So I get -2 is less than -2. You notice that it's this point right here. But it's on the dashed line. It doesn't work because -2 is not less than -2. -2 equals -2. So this is not true. So that point is not going to be in my solution region. What about 5, -3? Plug in -3 for y. I get 2.5 minus 1, or -3 is less than 1.5. That is true, right? If I looked at my graph, 5, -3 is right here. That does work. And 7, 1, plug in 1 for y. Half of 7 is 3.5. 3.5 minus 1 is 2.5. 2.5 is bigger than 1. If I looked at my graph, 7, 1 is right. Oops. 7, 1 is right here. That's in my solution region, so that works. Okay? So, in the next video, we'll continue graphing inequalities. We'll break that here. So, big thing is, if it's, let's see, where can I write this? I'll just write a little bit of tidbit over here. If you have equality, it's a solid boundary line. If you don't have equality, it's a dashed line. If it's less than or equal to, you shade below your boundary line. If it's greater than or equal to, you shade above the boundary line. Okay? And you can always test a point to make sure you're shading in the right way. All right, so that's going to wrap up this video. Next video, we will continue graphing inequalities.